Thank you, Julian. Let's see here. So yes, I'm David Peterson.
I'm Nick Benders.
So Nick and I are on the site engineering team here at New Relic. We're responsible for the care and feeding of all of our production systems, sort of on the pointy end of the stick from PagerDuty. So let's kind of start from the beginning here. So what you're looking at is actually our code base when we launch. So the blue cloud is the Rails app, the Ruby on Rails app that you interact with. The other part is our Ruby agent. It's pretty small at the time, ran on engine yards, platforms of service, a few virtual instances, a couple for the app, for the database, maybe 10 employees at the time. This is what it looks like now. So that Rails app has gotten much bigger, much more complicated. There's a bunch of other services that make up our production application stack, data intake pipelines, all in Java, things like that. At the same time, we've moved on to self-managed Cola facility. We're running on bare metal, small number of servers, and we're probably like 200 odd people, or 250 people these days. And this is what's going on the site right now. Probably about 100,000 requests a second, sort of across all the various services that make up our production infrastructure. Like 2 gigabits of bandwidth in from the internet, and about 200 terabytes of storage. And this all matters because as we've gone from kind of a no traffic to lots and lots of traffic, like things that didn't really matter at the beginning, they matter now. Like making errors is harder to recover from. You got to get things right to begin with. And so, kind of bad on the slides here, I apologize for that. But what we're going to talk about is a few of the things that we've done wrong, kind of setting up New Relic. Premature on the slide, but one of the things that we, go ahead,
So,
Nick.
again, as Julian indicated, so Dave and I have been lucky enough to be here for a while, and so we've had the opportunity to make lots and lots of mistakes going along. And we've also done some things right, and the things we've done right, by and large, are things that we got wrong at previous jobs. These are things that we screwed up in the past, and we said, okay, well, I'm not going to do that again. So what we'd like to do today is give you some of our mistakes so that you can go back and not make them in the future, or maybe identify something that you are doing today that seems like a good fit, but we're here to warn you, it will not stay a good fit.
Yeah, so the first thing I want to talk about is actually organizational, it's not technical. This idea of like who does what, and we're still trying to get this right. Like it's kind of figuring out like what is site operations, what do these people do, what's their mission, how does it relate to other parts of the company where you have people doing similar things. It's kind of, let's see, jump forward here. What we sort of, the conclusion that we've come to eventually is that site operations is not IT. Like we had them mixed together when we started up, and it was kind of a disaster in a lot of ways. Like I said, you've got similar things all over the company. You got computers, you got vendors, you got applications that need to be managed. Just have one group manage all that. You have the IT group. That's a pretty common notion in most companies. But the trouble is how do you kind of prioritize what's going on when the site operations people responsible for production are also your IT group responsible for all your internal stuff. Like, sure, if like the production site's on fire, you're going to work on that. But if the site's not on fire and someone spills coffee in their laptop, well, that's what you're working on that day. So what we've eventually done at New Relic, this is recent, a year or so ago, probably when we're about half the size of now, is actually make a hard break between the two groups. Like site operations only takes care of our production systems, the IT group takes care of all the other internal structure or internal infrastructure around running the business, and kind of training the rest of the company that these are two different groups with two different missions.
And I want to talk a little bit about how insidious this idea can be, because when you start the company, you've got just a few people, even fewer of them are technical maybe. So if you've got one woman who's really good with Unix, then you're like, okay, well she's the main developer for all the operational type of stuff, and then that role will grow, and soon enough that's a group, and maybe she's in charge of that group, and this group is still heading our file server in the office and also the production servers. And then as this grows over time, maybe it's not one group, it's a set of groups, but they're all in the same organization. Often when people talk about what we do, they say information technology. So it makes sense to put it all in one tree. It's impossible to balance the very different time frames that you have to be thinking between these groups. And you're always going to end up with one group stealing resources from the other when they least need that to happen. So be sure you separate the groups, give them different chains of command so that they can go up and get their own priorities. Make sure the IT group has people with operational expertise for running servers. Your IT department is going to need that kind of stuff, and your site operations needs the focus away from it. So be sure you resource both groups. The next thing I want to talk about is another one of these kind of classic IT patterns, and this is one that I've fallen into many times. This is definitely a mistake I was guilty of, which is that maybe you've got a bat cave. We have a bat cave. This is a picture from our office. But you are not Batman. You do not work at night. Work during the day. It's so tempting when, again, start small, harmless. You're like, well, I'm going to take the site down, make some changes. We got just a little bit of traffic during the day, so less traffic at night. I'm going to do these risky things at night. Well, the problem is that nighttime is still a busy time. So if this is the chart of page views on the rpm.newrelic.com site, and this is 3 days worth of time. You can see it's definitely got a nice traditional traffic wobble to it. It's not that low at nighttime. When you are taking the site down at night to do a maintenance, or when you are, saying, oh, well, we'll push this risky stuff live at night, those 60% of traffic that is still being affected at night. And it's really bigger than that. It's this idea that you can't just throw the cloak of darkness over an operation and say, well, we don't have to control risk. We're doing it at night. Anything that you can do at night, you should be willing to do during the day. And by doing all of your stuff during the day, so deploys during the day, maintenance during the day, background jobs during the day, if you run batch jobs, don't run them at night when, if they break, there's nobody around to fix them. Run them in the middle of the day. And it's about building the processes that are necessary to give you the confidence to run this stuff when everyone is watching. And when you get to there is when you're going to be happier with the quality of your product, and your engineers are going to be a lot happier because they're not trying to work Friday night on something that they could be doing Monday morning. The next thing I want to talk about is actually one that we got right off the bat. And it's a big hat tip to Byard Carlin, who made this decision against my advice. When we were looking to move from Engine Yard's managed hosting and go into doing our own colo facility, looked at a lot of different colos, and we looked at their redundancy systems and their bandwidth and their technology, and one thing we didn't look at was location. And I thought that was insane. I said, well, your server's going to break, and you're going to have to put somebody on an airplane, and they're going to be flying to Chicago in the middle of the night, and they're going to be miserable. No, that's the wrong way to think about it. The right way to think about it is put your servers far away from you. So if you're doing cloud hosting, you already have no physical access to your servers. Even if you're doing colo hosting, treat it the same way. Push your servers away, and then if you need work done, use the guys who are out there. Like, there are technicians at your data center, and if you have your planning together and you know what you're doing, it's easy to get them to do your work. When you go to a data center yourself, you're like, oh, well, I'm just going to put these 6 servers in. I'm going to look around and see what the best spot is. Or, I don't know, I'm going to try and debug this thing. You don't have a plan. If you know that you've got to get the Moonanites to do your work for you, you show up with a spreadsheet. You say, okay, 6 servers arrived today. Here is their configuration. I want them in these locations. You have tracking. It enforces good behaviors around the system. The other thing it keeps you from doing is opening the box. Never open the box. If your systems are in production, leave them in production. Do not pop the cover and be like, oh, you know what, I'm going to put some more RAM in this system. We made this mistake big time. And we had a tier of database servers, and we said, I think these would run better with more RAM. It was a huge operation to shut them down one by one, shuffling traffic around while we did it, bring them all back up, lots of nighttime maintenance windows. And in the end, 30% of them, the RAM didn't work. So they had to shut them down again, fight with the vendor. It was a ridiculous waste of time and energy. So don't open the box. If you need different servers, buy different servers, put the old ones to use doing something else.
Yeah, so that's our new mantra now, is never open the box. Don't take a screwdriver to your systems. You're just going to hate yourself. So another thing we want to talk about is kind of keeping things organized. Domain names are cheap. So are DNS zones. So why did we put everything in our newrelic.com domain? Like everything, my laptop, the printer down the hall, servers, the data center, they're all in our newrelic.com domain. And every time we go and touch any of that stuff is just an opportunity to destroy our customer-facing names, like RPM or www or things like that. And the thing is, this is ridiculously hard to clean up after the fact, because we just planted this out all over internal networks, all around the office and stuff, And newrelic.com is in the search domain that gets handed out by the DHCP server. So now we've got all these internal systems that talk to each other using the short names. And it's impossible to extricate this mess. So up front, get a separate domain for your internal corporate environment. Get a separate domain for your data center. DNS zones are cheap, domain names are cheap. Just do yourself a favor and do that from the get-go and keep all that stuff separate.
This is a great point. You put a lot of work into getting your brand right. Do not mess around with what is in that branded domain. It's the same as you would think about a production app. If I'm putting an app in production, it doesn't also include, all this miscellaneous, bookkeeping stuff to help us, keep track of our office supplies. Don't have the systems that do keep track of your office supplies in your production domain. And get a wildcard SSL cert is another thing. This was a big surprise to me when I started, is that the price of SSL certs, and particularly wildcard certs, has gone way down. So I spent years messing around with internal CAs for non-production domains. I'm like, well, all of these Nagios servers or whatever are going to have like SSL with my own CA because I don't want to spring for an official one. They don't cost that much. Just go for it.
Yeah, that's one thing to think about just as you're setting it up. Separate domains, separate SSL certs, save yourself lots of trouble later on. So in a similar vein, it's like, think about when you're setting up your network. What are you going to have more of, like subnets or things on the network? So we totally screwed this up. I don't really know how it happened or why, but we put together our data center network with like /24 Class C addresses. And 250 odd things on the network, not very many. And when you run out of network addresses, it's a total pain in the ass to then widen that out, go back to all those other systems, change the net mask so they can talk to new systems in the new range. So do yourself a favor from the get-go, like use /16s, go nuts. You're going to have way more things on your network than you have subnets, and it's the total hassle that you can save yourself by not just going with some default that your home router is set up with.
The next thing we want to talk about are hardware decisions. So as we mentioned, we have our equipment in a colo facility. We are almost exclusively hardware-backed, bare metal, very little virtualization, limited cloud stuff. So we've had the opportunity to make a lot of decisions, some of them good, some of them bad around hardware. Luckily, we had a lot of experience with this previously, so I would say by and large, we've done well with our hardware selections. But there are definitely a few things that we'd want to do differently.
Right, so the first thing kind of think about running your own hardware is, well, how are you going to put that stuff together? How are you going to manage those? So those of you in the audience familiar with Dell equipment probably recognize this screen. This is the DRAC interface. This is Dell Remote Access Controller. This is like super IPMI on steroids. It's got all sorts of crazy bells and whistles. This web interface you see here. Thing is, like, when we got our first batch of servers, like, none of us knew anything about IPMI. Figured, like, whatever, it's not worth the bother of learning that. A couple hundred extra bucks per server, just get the DRAC cards, and we'll just use that to set things up. But ever since then, that was 3 years ago, ever since then, every server we've gotten has also had this DRAC Enterprise card. And it's not about the cost, it's still not that. It's about enabling the laziness that comes with that. So we still don't know anything about IPMI as an operations team. Like, we know it's a standard, we know there's all sorts of great automation tools that speak IPMI and do a lot of this stuff for us that we spend, poking around in the DRACs. So we should have just done that from the get-go. Like, we should have just invested the time up front. It would have taken somebody a day or two to learn all there would be to know about IPMI, and we wouldn't be wasting all this time today. And so, like, the lesson there is just, don't enable laziness. Like, we took the cheap and easy way out time-wise, cost a little more money, but it was cheap and easy for time, and we've been leaning on that crutch ever since then.
The DRAC does a great job of giving you the same kind of access to a machine that's thousands of miles away as you have to a machine that's sitting right next to you. It turns out, for production systems, this is the wrong kind of access. So there's a lot of stuff in this pattern, and you'll see as you build out your own systems, maybe you've already run into these, that what's easy to do a few times and works well at small scale is holding you back at large scale. The ease of use of this system at small scale made it harder for us to build a system that was easy to use at large scale. The next thing I want to talk about is a common misconception. This is the response time of the rpmnewrelic.com app when run on different processors. If you had asked me for these numbers ahead of time, I would have bet money against the results we got. It turns out that all of the advice you've heard that says, well, for web applications, what you're really interested in is sheer numbers of cores or parallelism, blah, blah, blah. That's fine for scalability when that word means how many different requests can I run at once. But in its absolute case, you think about a web request hitting your system. If you had no one else in the system, the whole system is completely idle. One request is dropped in the top. It has to go down through the system, execute the code, build its response, and come out. The amount of time that one request in an idle system is going to take is gated by your CPU power. So on the left here is the 6560 that we use for our old app servers. And on the right is what we replaced it with after doing that bake-off. And you can see we got, with a switch of hardware choices, a 25% overall, like, top-line performance improvement. So that's counting, the entire app. 50 milliseconds is not a lot of time in many scenarios. But anybody here who's tried to tune a web app and said, we're going to drive the performance of this thing, we are just going to focus on, like, micro-tuning, 50 milliseconds is a lot. Well, this is an easy win, and it's just a matter of being selective when you're picking your hardware.
Yeah, I was really surprised at the performance impact of that. Like, I would have bet money that it was just, it's all about cache size and things like that. But there's a lot more nuance to it, and it's worth kind of spending some time looking into that. So the next thing I want to talk about is storage. So we've got a lot of it, about 200 terabytes or so, and all of it's SSD. So there's probably going to be lots of naysayers in the audience. But what I'm going to tell you, what's worked really well for us, what I would recommend to anybody, totally do again, is just use simple direct attached storage. Either put disks in your servers or get disk shells, put them in there, attach that to your servers. Like, it's dirt simple, it just works, and it's really easy. So, like, there's lots of storage companies out there that want to take your money, but what do you really need? Like, what are you really looking for? Probably moderate amount of disk space, lots of IOPS. You can totally get that with direct attached storage. And you can get an SSD, an 800 gig SSD for about $1,000, 24 of those in a disk array. Super ultra conservative RAID 60 format will still get you like 15 terabytes of disk space and near infinite IOPS. Plug that into your server. It's directly underneath whatever your database, your application, wherever you need it. It's there, it's simple, it just works. You don't have any crazy SAN configuration. There's no special drivers. You don't have like a separate sideband iSCSI network or fiber channel card. There's no special drivers. And there's no specialized personnel. Like, we don't have storage engineers at New Relic. So not a whole lot more to say there. It's really just like your best thing is just go get fast disks, plug them to your servers, and be done with it, and just don't mess around with SAN stuff.
The one extra thing I do want to say about that is, so what we ended up doing for kind of very random reasons at first was putting our disks in external shelves and then attaching them via these external SaaS cables. This works great. It gives us the portability of being able to, we've retired one server, we just take that disk shelf, move it in the data center, plug it into another server, or replace server heads. It's very nice, it's lasted well for us, and we get huge performance, and you always know how to correlate a performance issue with the server responsible. There's no indirection involved. It's, if you're running hot volumes, I/O-wise, they're on that server, you can just look and see the cables. The next thing we want to talk about is a little less direct, the databases. We get a lot of questions about what we use for database storage, and you've heard from Alex and from Lou all about the codename Rubicon data storage engine. We're not going to talk about that today. It's kind of the next generation technology. Prior to that, all of our data is in MySQL. And every engineer at New Relic, on their first day at work, they connect in, and then they say, well, you're not really using that in production, are you? And they say, this is a terrible idea. It can't possibly scale. It won't last more than a couple of more weeks, certainly. And I said that, 3.5 years ago. I'm sure Dave said that, when he started. It has scaled, and it does have limitations, but it has strengths. And those strengths are not necessarily technical. Those strengths are in the tooling and in the community and in the support. It's a lot more important to have a system that you have reliable backups for and you have a good chance to debug than it is to have a system that has no bugs. So MySQL has worked really well for us. It's been a big success story in underthinking the problem. But we did stub our toes. So those of you who've worked with Rails will recognize this, active record migration. So we're just adding this into our system. We write a bit of fancy DSL language here. We say, well, I'm going to need a new table. It's got these fields in it. So then active record will turn this into SQL for us. And what it'll turn us into is it's going to generate this implicit ID field. It's going to say, you get an ID. It's an int type. It's not null auto increment. That's great. and off you go. And we have, hundreds of tables that have this field in it. Well, int is a 32-bit signed type, so you get 2 billion objects in there in the entire life of that column. And when you run out of them, you are going to be very sad, because now you have a table that has maybe 2 billion objects in it, and you need to run a migration on it. It's going to be extremely painful. Anything that you have that automatically creates and destroys new records over time is going to hit this limit eventually. And we found that it hit it a lot sooner than we thought. The guys at MySQL have a solution for you. Rails is just leading you down the wrong path, which is you need something more like this line, where we want a 64-bit, a big int, and we want it to be unsigned, and it's still a not null auto increment. And it turns out that so many people want this that there's a shorthand syntax just called serial. So if you're using MySQL and you're using Rails, serial is your ID field, and that will save you untold hours of pain and suffering. The next piece about the database is a little bit more subtle. You might have heard someone tell you this before. Your database is not a queue. You're like, well, I don't know. Sure it is. Like, I put records in this table, and then I reap them off the bottom. Why not use my database as the persistent store? This is a story about why not use your database as the persistent store. This chart, the chart here shows our delayed job queue. So delayed job functions exactly like I described. You put records in, you find them, and execute them. And so we started seeing this happening once we were monitoring our delay jobs. You see that it would ramp way up. So the numbers here, are a queue that normally has 100, 200 items in the queue, going up to 150,000 items backed up in the queue, which is obviously very bad for whatever it is we're trying to do. And this is the cause, so jump into New Relic, we say, okay, what are you spending your time doing? We're spending our time not executing the jobs, but calling the active record job find method. So it's taking the majority of time just to find a new job. The reason is that we had a long-running query going off at the same time. And so you see, if you read the time frame, this starts off at about 3:30 in the morning because we were running background jobs at night, like you do. And the history list just grows and grows and grows. InnoDB has some degree of transactional integrity. And so in order to enforce that, when you have a transaction open, including a single query transaction, it keeps track of all the changes that have happened to the entire database, not just to the table, not just to one schema, across the whole database instance. And just keeps track of them. And so every time delay job was trying to find a new record to select against, it would have to replay this list of 25 million changes to make sure that it was getting in the right state. Just destroys the performance of the system. And not long after delay job is affected like this, you'll find the rest of your database systems are affected. The solution is actually pretty easy. Don't run long queries against your production database. Put in place protections against this. Maybe you can't get off of using delay job right away. It's not a production system because it's easy to change. But you can stop doing things that are dangerous to it. And what we did was we took kind of multi-pronged approach. We put in place a replica database that people could run their read-only queries against, and we put in place a hard query limit. We said any queries that run for more than an hour, no matter who they are, whether it's a backup, whether it's somebody running a reporting query, somebody doing something ad hoc, query gets killed. And that protects the system from people who are accidentally or unthinkingly bringing down the performance.
Yeah, that definitely took us a while to figure out. Just would not have bet that a simple select using a read-only user essentially have a transaction that's going on for hours.
And the pattern of limits, unless you want to, the pattern of limits is really powerful too. Is that this was hard for us because we didn't have a limit in place at the beginning. So it used to be none of our queries took very long to run. You run against a small data set and they're fine, and it kind of grew over time. And as you can see on this curve, the performance doesn't explode immediately. It kind of takes a while. So we had to finally diagnose this, and then we had to put the query limit in place, and this was difficult for the teams who were affected. If we had that query limit in place when we were small, then nobody would have accidentally built a system that depended on a multi-hour query. Our backup scripts would have already have been aware of the fact that they were holding transactions open. Our reporting scripts would have been written to work in smaller chunks. we had the same thing happen with memory usage, both in our web apps and in our batch jobs. It was difficult for us to go in after the fact and say, large batch jobs are causing performance trouble for other teams. We're going to establish some kind of limit and push down on it. It would have been very easy for us to put that limit in place first and say, you know what, 5 gigs of memory is way more than you possibly need. Put it in place using ulimit, and then that way, instead of having someone from site engineering calling someone on another team on the phone or in HipChat and saying, hey guys, your jobs are running kind of big, the machine would just show the developers the right limit. You know, you write a program that takes up too much memory, it gets blown up, and you say, okay, that's fine. I've got a stack trace, I can fix it. Get the limits out in front of the process. Don't wait until afterwards when you already have trouble.
Yeah, so that's like a notion that we're sort of taking to heart now, this idea of just defending the site and having limits all over the place, limits on query time, limits on RAM usage, all that kind of stuff. It's a mistake that we made early on, and we're kind of slowly digging out from under that and setting those limits, like like Nick said, so that people know about it ahead of time. So that's actually kind of what we had for presentation. But before moving on, I wanted to let you know about the other folks on the site engineering team. Many of these folks are out roaming around the halls, so if you run into them, you can say hi, thank you. They're the ones that are sort of cleaning up a lot of the mistakes that Nick and I have made. So if you get a chance to talk to them, buy them a drink.
Thank you.
Enjoy lunch.